Good morning students. Now we are going to perform an experiment to determine the wavelength of spectral line using diffraction grating. This is a diffraction grating sheet which is nothing but a transparent glass material where opaque rulings are made with a diamond point. The number of lines on the grating is given by the manufacturer itself, which is specified in the grating sheet here. Now we will see how to perform this experiment. This is a mercury vapor lamp and this is a spectrometer. A spectrometer is basically an optical instrument which is used to determine the properties of light like wavelength. So for finding wavelength now, we are now making use of this spectrometer. Now there are some initial adjustments in the spectrometer. We will see how to do the initial adjustment. If you see the spectrometer, you would be able to see this collimator. So the light from the mercury vapor lamp reaches the collimator, and by adjusting this screw, you would be able to adjust the thickness of the light which is entering through the collimator. And this is a prism table which is rotating in nature. We would be able to keep the prism or the diffraction grating in this table. And this is a telescope. Now the light from the collimator actually reaches the telescope, and we adjust this screw so that through the eyepiece we would be able to see the clear image of the slit. If you see through the telescope, you would be able to see the image of the slit this way, and we need to see to that the slit is actually coinciding with the cross wires in the telescope. Now what we need to do is, we need to move the telescope either to the right side or to the left side, so we will be able to see the color spectrum. So if you rotate this screw, we would be able to see the colors, and those colors, if you see through, you would be able to see the colors this way, starting from violet, blue, indigo, green, yellow, orange and red. Now, if I want to find the wavelength of this blue color, what I need to do is, I need to adjust the telescope in such a way that the cross wire coincide exactly with the blue color, and I need to take the readings. Now let's see how to take the reading in this spectrometer. The details of how to take the readings in the spectrometer, we will see it in another one video. Now we will see it how you can take the reading. So there are two verniers here in the spectrometer. Let us say, for example, this is vernier A and this is vernier B. Now in this vernier, you would be able to see a main scale and you would be able to see a vernier scale also. So you have to make the 0 coincide with that, and you have to take the main scale reading, and then among the 30 lines, any one of the line would exactly coincide with the main scale reading that is nothing but your vernier coincidence. So you need to take readings on both the verniers here, and now let us see how to find the wavelength by taking the readings there. Okay. So like this is the colored line. Suppose if the yellow one line you are focusing on, first we are doing for the first order spectrum. So now this is vernier A. We need to note down what is the main scale reading, vernier scale reading, then the total reading. The same way now I need to move the spectrometer in the other side. Again I would be able to see the color starting from violet till red. So now I need to take the reading, and I need to note down the main scale, vernier scale and the total reading here. The difference in between the two total reading would give you 2 theta. From that, I would be able to find out what is theta. Now, I need to substitute the theta here in this formula for finding the wavelength, which is nothing but lambda is sine theta upon capital N into small n, where capital N is nothing but the number of lines in the grating and small n is nothing but the order of diffraction. So now the diffraction grating sheet, what we use is having 15,000 lines per inches. So we need to convert this into centimeter, and we need to write it over here. And n is nothing but order of diffraction. So for the first order diffraction, small n we need to put as 1. So if we substitute all the value, we would be able to find out what is the lambda here. Thank you.